is set up double integrals given situations that involve double integrals. So this is now just taking the situation you're given, setting up the double integral, and then doing what you're doing in 14.1, 2, and 3, which is calculating double integrals, either in rectangular coordinates or if it's advantageous in polar coordinates. So I'm just going to go through some of the applications, but you saw these in the videos. We already know double integrals can be used to find areas. You know, if you set the function to be 1, then what the double integral is doing is finding the area of this region. Same thing would go with this example. If this function was just set to be 1, then we'd actually just be finding the area of that half circle. Total mass. So if you have a varying density over your surface, then integrating over that density would give the total mass of that surface. Right? Very similar idea to what you saw in Calc 2. And if we can do total mass, we can do center of mass. All right, do not worry about memorizing these formulas. You know, you guys can use your note cards for them. I don't usually put center. I wouldn't put center of mass on an exam anyways. This would be more like a take-home type of thing. But you know, we can do center of mass. It's again very similar idea to what you were doing in Calc 1, except in Calc 1 you were looking at the moment in either the x direction or the y direction. Now we can look at the moment in the x and y direction in a two-dimensional surface. And then just a note of being careful, just because of the way it works. M sub y is the tendency to go about the y-axis, which means it's actually in terms of x. So it's actually used to find x bar. So and it's something, like I said, you're not memorizing these formulas, so it was something you would have on your note sheet anyways. But just, I always like to point that out because it can be a little confusing that M sub y gets used to find x bar. And the reason is because we think of it as the moment or the tendency to go around the y-axis, right? Well, if you're going around the y-axis, you're changing the x's. Total charge. All right, so if you've got a charge density, doing the double integral will give you the total charge on the surface. And again, you know, these aren't going to be, they're going to be really obvious because you're going to see in the problem, oh, I'm given a charge density right here. That's what I'm integrating over. And then most of our work, or most of what we're going to do, is figuring out what the region is and setting up the limits. It's going to be pretty obvious what you're integrating over most of the time. Probability. This is another one that involves double integral. So if you have two random variables, x and y, then you get a probability that creates what's called a probability density function. And those can be integrated over to actually calculate the probability. So if you take any calculus-based statistics courses, a lot of times you actually don't do these calculations yourself. They've already been calculated in tables, and you base off of your A, B, and C, and D, you look up in the table what the probabilities are. Well, actually, nowadays you probably don't look them up in tables anymore either. You probably just put it in the computer. But again, the key is setting it up. So that's going to be the thing with these application problems. Probably the actual integration you're going to find not any more difficult than what you're doing in 14.2 and 14.3. The big thing is going to be setting them up, because that's what we do in practice, right? We can always use a computer to solve a double integral, but the computer can't set it up given our situation. Is probability the last one? No. Oh yeah. I'm gonna leave that because I think that might be on the worksheet. So, but basically you got this probability density function, and you're integrating over this rectangle that would make up your limits. Okay. So again, I kind of just went through some of the applications that we would see depending on what route you're heading after this. There's going to be other applications. You'll see them in the homework. But what we're doing, it's going to be really obvious that, hey, oh, I want to use a double integral here. I know what I'm integrating over. I'm integrating over this charge density. Oh, what's my region? So we're going to be, most of our analysis is going to be in figuring out the region of the surfaces so that we can get our limits. Is it better to do it in rectangular or polar? Okay. If you guys don't have any other questions, that was all I wanted to talk about. Like I said, I wanted to spend more time letting you guys practice double integrals.